Hi, welcome to the project presentations of Places Insight. This is a natural language search engine implementations for places and business. My name is Ahmad Rahadian Hutomo or Ian. I'm doing this project with Yang Liu or Eric and also Alexander Nestle. So this project is actually to fulfill the final project requirement for courses 410 Text Information System in the University of Illinois at Urbana-Champaign. Places Insight is a search engine implementations that allow users to query a database of business or point of interest. So user can search using a natural language attributes such as child-friendly Italian restaurants or jazz bar, or by activity like hiking or surfing, or even by objects as well, such as jazz or toys. So we implemented some of the natural language processing topics that we learned from the courses. This is an overview on how we built the software. So we started to scrape the data of places, including name of the places and also reviews. We took this from a Facebook travel recommendation page, and then we do some kind of data cleansing and text processing and generate a places data set in a JSON file. So from this JSON file, we built an inverted index for the search engine purposes, and we store this data in a data index.json and also data.doc.json. We also implemented a topic modeling using LDA topic modelings and store this in the topics.json. And then this is the search implementations for the software. And then in terms of using ranking, we are combining BM25 ranking and also topic modeling and weight that based on the topics related to the query. And then places show is actually the implementation where we consolidate all of the results. And then we use Flash and Bootstrap to actually show this in the web front end. So I will go through one by one. So the first is actually dataset collection. So we scrape a Facebook travel page recommendations and generate a JSON file based on that. You can see the sample of the scraped data in the right hand side of this slide. And then we do some kind of data cleansing and text processing. So for example, removing the duplicates places, removing places with so little views or little words per reviews. And then after that, after we scrap that into a JSON file, so we use an inverted index Python code to generate an inverted index. So it will map all the terms into a document ID, as well as map the document ID to a document key. And then we store this into an in-memory database using config.py and config.json. Next is actually we also do a topic modeling using an LDA topic modeling. It uses the Gensim module and a PyLDFs for the visualization. This is a sample of the topics that generated from the files. For example, you can see this is the topic number 4. It has a lot of words like fry, burger, chicken. This might shows that this is actually a fast food restaurants. So we use this topic model informations to improve our search engine. Next is the ranking algorithm. So we are using a mix of BM25 and weighting based on the topic models to rank the documents related to the query. So we use this formula. So 1 plus C over N. So C is the reviews of the place mentioned in the query topic, and N is actually total number of reviews, and we just multiply that by the score from the BM25. If a query doesn't have a topic related into it, so we will just use BM25. Next is actually we use placesearch.py as an implementation for the search. So it's basically load the index from JSON files and process the user query. And then lastly, we have places show. So basically it will display the result based on the document key. And then we use Flash and Bootstrap CSS as a web front end. This is how to install the software in your machines. First, you need to install all the required Python modules and resources. You can do that by inserting this command pip install -r requirements.txt in the terminal of your machine. We listed down all the required modules and downloads in this requirements.txt. Alternatively, you can also run the commands on the right-hand side of the slides. After you install all the Python requirements and resources, you need to enter the folder src by using command cd src, and then you can run the app.py using the command python app.py. So after all the servers are up, you can go to your web browsers and launch the local host on port 5000. Alternatively, we also deploy this application on Heroku, so you can follow the link on the slide to access that. Next, we are going to do the demo for software installations. Now we are going to install the software in my machine. So I already downloaded all the required files to this folder. So I just run this command to install all the required files. So we already listed out all the required modules and downloads in this requirements.txt. So just need to run pip install -r requirements.txt. Or the other option is actually you can also go to the documentations and also and install the modules all one by one. We listed down all the required modules and the files that you need to install in that documentations. So as you can see now, the pip will install all the requirement files. Okay, after all the modules are downloaded and installed, so we just cd to the source folder, cd src, and then we just run the app.py application. So this command will run the servers and also the software now can be accessed um, in the browsers through localhost port 5000. Okay, now the code are running the servers. So now it's run. As you can see, it's running on the localhost. So we just need to open the browsers and head to the localhost port 5000. You can put the IP or the localhost there, and then the software will run in this. Next is how to use the software. You can just go through to your browser and localhost port 5000, and it will load up the home page of the search engine. Then you can just put in your query in the search box. This is a list of sample use case of a natural language query that you can use with the search engine. First, we can search by the place of interest, such as a park or library. You can also search by a business type like coffee shops or Thai restaurants. And then the search engine is also able to search by a certain use case like child-friendly Italian restaurants. The other use case that you can try is actually search by activity like hiking or surfing, or by objects like latte or any type of coffee you want, jazz or toys. Now we are going to demo the software usage. Now we are going to demonstrate how to use the software and what you can do with it. So this is the home page of the search engine where you have the query box here. So you can just, let's just start by searching for a Thai restaurant. So if you hit enter or click on the magnifier icon there, so it will show you the result of the search. So here you can actually browse for the places that returned by the search engine, and then you can see what are the topics for each of these place. So the topics is generated from the topic models that we built on in the software. So you can also browse where is the location. We are using Google Maps API here, and then you can also reviews what are the reviews for this specific Thai restaurant. Right, it will return the most relevant topics related to the query search. The other way you can use it for is actually there's a search box as well here. So let's try using more kind of natural language search. Let's try with child-friendly Italian. So it will do also the searching into the database, and then it will shows the most relevant places. So um, here you can browse the results as well as see what are the tab topics that you might be interested in. The other things that we can do with the search result is actually, let's go back to home right now. So you can also search by an activity. Let's try an activity of hiking. So it will also shows the relevant places, perhaps that's the most relevant with the activity hiking. So you can also see the reviews to see what are the people saying about this place. And then let's try one more use case when you are trying to use a query where it's actually an object. So the search engine can identify places by, for example, object. Perhaps it has been mentioned in the reviews. So for example, jazz is a music, but this search engine can find a place that's relevant to this. Perhaps it will show some jazz bar or some music store. So this is a brief explanation on what the software can do. Now we are going to discuss any possible further improvement for this software. The first is actually expanding the dataset using a different source of datasets like places or any other dataset. Second is actually improving the software by using more scalable database, for example, such as any NoSQL DB implementations. The one thing that we haven't done is actually to benchmark the performance of the search results compared to any of other search engine and available services for searching places. The other thing that we can improve is actually we are using simple BM25 and topic model weighting for this software, but we can try and benchmark and find a more suitable ranking algorithm that has a better performance. The other thing that we can explore is actually right now we are using one set of parameters for topic models. We generate 40 topic models, but we can also explore to have more topic models and perhaps have a tag for each topic to give a better results. And then we are also experimenting on doing query expansions and improving the research based on the user feedback using pseudo relevance feedback. And then, of course, what we hope this software can be used by some organizations, like, for example, travel organizations or city organizations, to be used as an open API to search for places in their organizations. That is all for the presentation, and thank you for your attention.